Hello everyone, welcome to JalVishwa. In this tutorial, we will be understanding how to use the life cycle costing tool, which is integrated in the JalVishwa tool. Before moving on to the actual user interface, we will just understand the significance of life cycle costing in decision making when it comes to technology selection for wastewater treatment. This illustration represents a cash flow diagram of a typical sewage treatment plant. As you can see, there will be some capital cost incurred, which will comprise of land cost or electromechanical and civil construction works. Then there will be some replacement cost after, let's say, 10 or 15 years. Then there will be an annual operation and maintenance cost throughout the life cycle of the sewage treatment plant. Let's say we have another technology option with this cash flow diagram, in which the capital cost is relatively higher than that of the first technology. However, the annual O&M costs and the replacement costs are substantially lower as compared to the previous technology. In this case, the confusion will be as to which technology option should the urban local body go for. As you can see, wastewater treatment often incurs a trade-off between the capital costs and the operation and maintenance cost. And in order to bring them on a comparable basis to compare two different technologies from the perspective of costs, it is the life cycle costs that together co- account for both the capital costs as well as the operation maintenance and the replacement costs, basically all the cost components incurred throughout the life cycle of the project. So those are collectively termed as life cycle costs. And the present worth method, as prescribed in the IS code 13174 part 2. So this is commonly used method for determining the life cycle costs. And this is the methodology that has also been adopted to compute the life cycle costs in JalVishwa tool. So this is the interface for the life cycle costing tool. You can access this from the button which is on the left hand side. Alternatively, there's this life cycle costing framework tab, which gives a brief about the need for life cycle costing and its methodology. You can also go through it, and from there you can use this button to access the life cycle costing tool. As you can observe, the project details is the first section. So let's say for my project, the life of the project is 30 years. The rate of interest is, say, 10%. Land price, say, 4,000 rupees per meter square. Energy price is 5 rupees per kilowatt hour. As you can observe, the land price and energy price will affect the land cost and the energy, that is the operation and maintenance cost. So even if one technology is adopted in two cities or one in rural or urban area, for the same technology, the life cycle costs will be different because of the differences in the land price and the energy or the tariff at the two areas. And that is why this dynamic life cycle costing tool is integrated in JalVishwa, so that according to the user or the location of decision making, the user can have the representative life cycle costs for that place and that technology. The project details will remain same for all the technologies. So let's say I am selecting activated sludge process. You have to click here. So the name of the technology will get fetched here. And then whatever details you are entering, for whatever cost details you are entering, those will be applicable to activated sludge process. Let's say my land area requirement is 1,000 meter square. civil or construction works is 400 lakh per year. Now, since the life of the project is 30 years, the sewage treatment plant will bound to face some replacement costs. Typically, these are considered as a percentage of the construction cost. And alternatively, part-wise replacement can also be adopted, which I will show later. So let's say for activated sludge process, after 15 years, around 30% of the capital cost is what will be required to replace the components. Then the energy consumed, let's say 0.18 kilowatt hour per kiloliter per day. And similarly, the manpower requirement, chemicals, routine maintenance, and revenue generation. So say the STP is selling treated wastewater to a nearby industry or for some non-potable reuses, then some income is being generated. So that can also be incorporated in the life cycle costing. And operation and maintenance cost, as you are observing, has been represented in the different components in terms of energy, manpower, chemicals, and routine maintenance. So depending on the details of what the technology for that technology, the detailed cost components you have, you can fill in these details. So I will now generate the life cycle costing report. So in this report, the first page, it provides the inputs that we have provided for that technology. And then the outputs are computed in terms of capital cost separately, replacement costs, O&M costs, revenue generation, and in summary, the for activated sludge process for the given project details, the net present worth without and with revenue is reported in lakhs. So this is how the life cycle costing tool can be used. Now, let's say you have to compare two technologies, and instead of activated sludge process, let's say you take membrane bioreactor. After clicking here, membrane bioreactor will appear. And as you observe, all the parameters are blank. So now you are ready to enter the details for another technology. Kindly note the project details here will remain the same. So I am not changing because it's a comparison of technologies which you have to do. So let's say for membrane bioreactors, I am feeding in some other data. Now, in case of membranes or in even for any other technology, if you have detailed data for part-wise replacement. So in case of percentage of construction cost, as I mentioned earlier, if we take it as a percentage of construction cost, the assumption here is that you are replacing after 15 years. However, if you have detailed data as to for a given technology, different parts are replaced after different time intervals, then you may opt for part-wise replacement when you are computing this cost. So let's say I have pumps, motors, filters, membranes, and some other tanks which need replacement. So I am just entering some random data which may not be representative. Now, let's say my pumps need to be replaced after 15 years, my motors after 10 years, filters after every 5 years. Membranes, however, need to be replaced at a higher frequency of, say, 2 years, and the tanks after 20 years. You may like there will be less components, so it depends. Uh, for a given technology, you can fill one or two parts only that will need major replacement, and that you have to consider in life cycle costing. That is flexible. So again, for parameters, I am entering some cost components. So one thing that you have to be careful is the units. Because there is a formulation in which the life cycle cost is obtained in lakhs. So provided the computations will be correct if you are entering the data as per the units which are mentioned here. So it's very important for the user to uh, note down the units in which the costs are represented. So now for a different technology, I am generating the life cycle costing report. As you can see here, the only change is in terms of replacement cost. So we have adopted a different mode of entering the replacement costs. And again, my outputs will be the same with and without revenue. These much INR lakhs. So here you have to note that the purpose of life cycle costing tool is also that you can integrate it further with the decision support tool. So in order to do that, whatever technologies you will be considering for decision support tool, and if say life cycle costing is one of the indicators that you are planning to use, then you will have to individually obtain the life cycle cost for your project and make a note of this summary, like the net present worth with revenue. So this is the life cycle cost which you should note for different technologies, and as that will be the data set which you will feed into the decision support tool. So this is something that you need to remember. So that is all about the life cycle tool. Another thing, just in case of if you get any error, it might happen. Like let's say if you have not filled in the life cycle of the project, and then if this is the data, and then you generate life cycle costing report. In this case, your costs, as you observe, will be 0 because the N, like since the life of the project is not mentioned, so your operation and maintenance costs will not get computed. Then if you fail to also type in the rate of interest, and let's say this is there, and then if you generate the report, then also report will be generated, but there will be an error because the rate of interest, which plays a key role in the O&M cost and revenue generation. So this will not be applicable, and hence the life cycle cost will also not get computed. So it is essential that you just pay attention that you are filling in all the details and accordingly then using the tool. Okay, that's it. So in the next tutorial, we will see how to use the technology selection tool. Thank you.